Good morning, guys. Mr. Middleton here. Um, Today we're going to talk about operations with radicals. Okay. By the end of this lesson, you should be able to perform operations with radicals. By operations, I mean addition, subtraction, multiplication, maybe even some division. We won't talk about division, but that's what I mean by operations. Okay. The major point to some of these operations, I guess we'll talk about adding and subtracting. This is pretty much like variables, okay? Pretty much like dealing with variables. In this case, like radicals have the same radicand, just like terms have the same variable to the same exponent, right? So we'll look at those problems, talk about how to multiply, how to FOIL, okay, and how to add and subtract. So our first problem, we have radical 2 plus 3 radical 2. Okay, we can look at this problem as x plus 3x. If I asked you what that was, you'd say pretty quickly, oh yeah, that's 4x, because I have 1x and I'm adding 3 more x's to it. Well, that's the same as this problem. If I say radical 2 plus 3 radical 2, when I add those together, that gives me 1 radical 2, add 3 radicals 3 radical 2's to it, I have 4 radical 2's. Okay, and so that's my final answer. Okay, always check to make sure that these radicals are simplified, but in this case it is. Alright, number 2, I have radical 10 minus 5 radical 10. Again, I'd approach this the same way as if I said y minus 5y. So y minus 5y would give me negative 4y. Radical 10 minus 5 radical 10 would give me negative 4 radical 10. Okay. Now, one time where this is different than variables is that sometimes they look different at the beginning of the problem. You would never see a problem that I say 7x minus z and you'd be able to subtract that or simplify it. You wouldn't be able to do it. But with radicals, it's possible that we start off a problem with 2 different radicals and we can simplify it further. Okay, because radical 12, in this case 7 radical 3 minus radical 12 isn't in its simplest form. So we can say, hey, can we simplify radical 12? If I try to do that, I have 4 and 3, 3's prime, 2 and 2. Radical 12 is actually 2 radical 3. And so my problem becomes 7 radical 3 minus 2 radical 3. Can I simplify that? Can I perform operations here? Yeah, I can now, because now this is radical 3 and this is a radical 3. 7 radical 3 minus 2 radical 3. How many radical 3's do I have? Well, now I have 5 left. Notice that the radicals don't change. They stay the same. Still 5 radical 3's. It's not 5 radical nothings. I need them to be the same because they don't change. Okay, if I have 7 pencils and I took away 2 pencils, I have 5 pencils, not 5 nothings. Okay. Looking at number 4. Okay, we have 3 radical 20 plus 2 radical 5. At the start of the problem, we can't just add these together because they're not like terms. They're not like radicals. And so, I will try to simplify this. 4 and 5. 5 is prime. 2 and 2. Okay, I have a pair of 2's. That goes on the outside with my 3 that's already there. I have a 5 without a pair. Still have 2 radical 5. So 3 times 2 is 6. 6 radical 5 plus 2 radical 5. I have 6 plus 2, 8 radical 5's. Okay? Hopefully that makes sense. You see how we're able to change sometimes radicals that are not the same into like terms. Now, that doesn't happen all the time, but I'm showing you instances where you can do it. There will be some cases where you can't add them or change them to be the same. So, in an instance here, write some extra space. You don't have to write this down in your notes. If I had 7 radical 3 plus 2 radical 5, there's no way that I would be able to write this out any simpler. Okay, this would be my final answer. Okay, it would just be like me saying 7x plus 2y. I simplified it as much as I can. This is it. Alright. Okay, let's talk about multiplying. Alright, when we multiply, we kind of add a level, of complexity to the problem, because now we have to deal with, can we simplify? Can we add them after we simplify? But it's nothing that we can't handle. So this first problem, I have radical 3 times radical 6. Okay, these are both inside the radicals, so I can multiply them. I have radical 18. Okay, I have radical 3 times 7. This is inside, this is outside, so we don't really change those up. It's just 7 times radical 3. Okay. Okay, now I'll simplify this. That's 9 and 2, 3 and 3. So radical 18 breaks down to 3 radical 2. That's just 7 radical 3. Can we do anything with this? No. Can't break down radical 3 any further. Can't break down radical 2 any further. These two are not like terms. This is our final answer. Okay. Alright, number 6, we'll do the same thing. Radical 2x times radical 6x. When I multiply those, these are both inside, so I have radical 12x squared minus 11 radical 2x. Okay, outside times inside, we don't mix and match, they just stay the same. Okay, kind of put them together. Alright, so now I'm going to find my pairs. That's 4 and 3, so 2 and 2. So I have 2x, because I have a pair of x's. Radical 3, because the 3 had no pair by itself. Minus 11 radical 2x. Okay, I can't simplify radical 2x anymore. I'm not going to confuse myself because this 2x is outside and this 2x is inside. So that means they're not like terms. Okay, they're not like terms because I can't do the inside and the outsides together. Okay, it would only be like terms if they were both inside the radical. Okay, last problem here. If you're missing the box method, we can bring it back for you. We have to FOIL. We have a subtraction here times an addition here. We can FOIL, go first, outsides, insides, last if you want to. If you missed the box method and you loved it so much, you could also do the box method. Okay, if I make a box, maybe a little bit bigger. Okay, 1, 2, 3, 4. Okay, I can do radical 5 here, minus 2 radical 15. I can do radical 5 here, plus radical 15, so that's just there. And then I can just go around. This will be radical 25, which is 5. This will be negative 2 radical 75. This would be radical 75. This would be radical 15 times radical 15, so that's just 15. That's be 2 times 15, or 30. Okay. Alright, and now I can try to put together like terms just like we had before. So I'm just going to write them all out actually. I have 5 here. I have, so 5 from this box. I have negative 2 radical 75 and radical 75 and 30. So all that from the box. Again, you'll get the same values whether you use the box or you use the FOIL method. Doesn't matter to me. You'll get the same values. Combine our like terms, so 5 and 35. I combine those, I get, 5 and 30. I combine those and get 35. Alright. I have negative 2 radical 75 plus radical 75. So that just gives me negative radical 75. Okay. And I added these together right now without simplifying because I thought that they were the same. Okay, and I'd have to simplify both of them separately if I didn't just combine them. So now I'm going to simplify this radical 75. That's 25 times 3. That's 5 and 5. I have 5 radical 3. So I have 35 minus 5 radical 3. Okay, I simplified that as much as I can. These are not like terms. This is radical 3. This doesn't have a radical 3. So that's my final answer. 35 minus 5 radical 3. Okay, I noticed the most in this chapter in this section, people tend to not want their final answer to look like this. It's okay if your final answer looks like this. You just need to make sure that both of your radicals are simplified and they're not the same. If that's true, then it can be an expression. It could be just like we did when we had to do 7x plus 2y with our standard form or anything that we had to do in the first semester, okay? But all the rules still apply. You need to make sure that your final answer has simplified radicals in it as much as possible. But then it's just making sure you kind of go slowly and you check your work. Alright? Alright, well, now you should be able to perform operations with radicals. We did addition, we did subtraction, we did multiplication, we did not do division. But you should be pretty set to do that. See ya.